Alright guys, let's do this problem that says determine the moment of the force about point O right here. So basically the first thing that I like to do is to calculate the x and y components of the force. This is the y. So the magnitude of the force, let's say this is the force F, the magnitude of the force in the x direction is equal to 600 pounds cosine of 20, which comes out to be 563.8 pounds, and the magnitude of the force in the y comes out to be 600 pounds sine of 20, which when you plug it into your calculator it is 205.2 pounds. So this one is 563.8 and this one is 205.2. The next thing you want to do is draw your lever arms. So this will be the lever arm that this force is hitting, and these will be the lever arm that this force is affecting. Now that you have both lever arms, you gotta figure out the lengths. So the length of this lever arm is equal to 5 feet cosine of 30, which will go all the way from here and a little bit over to here, and then 5 feet cosine of 30 minus 0.5 cosine of 60 degrees. I'm going to explain you where I got this 60 degrees. You know that this whole assembly is tilted at 30 degrees. This is 30. And you know that this is like a straight angle of 90 degrees. So this angle right here is simply equal 180 minus 90 minus 30, because this whole angle right here is 180. Therefore the last angle is 60 degrees. So 0.5 cosine of 30 will give you the length of the arm from here to here, a little bit over. So we have to go back to here by subtracting 0.5, this length right here, cosine of 60. And I show you how I found this angle. Now that you have the angle and you have the length of the arm, you calculate it, and you get that it is equal to 4.08 feet. And then you need to calculate this length of the lever arm, which is calculated with the same principle. 5 feet sine of 30 this time gives you the length of the lever arm all the way to here. But you gotta add this last little piece, which is 0.5 sine of 60 degrees, which comes out to be 2.93 feet. Now that you have the length of both lever arms, you can calculate the sum of the moments. Going counterclockwise is positive around O. So the first force of 205.2 pounds is pulling the lever arm counterclockwise, which means that it's positive. So this is 2.93 for the length of the lever arm. Now the second force is pushing this lever arm counterclockwise as well. So it's also positive, and it has a magnitude of 563.8 pounds. And the length of the lever arm, which we found right here, is 2.93 feet. When you plug this into your calculator, you get that the lever arm, the sum of the moments around O comes out to be 2489.2 foot-pounds, which is also known as 2.4892 kilopounds per foot. And since the value is positive, it means that it's going counterclockwise. Final answer.